one program which was compiling and running with in 2012, we still compile and run in 20. That's C++11 and C++14. And now we have a 6-month release cycle. Release 1.9 was actually just released a couple of hours ago. So right on time, because we are on August 1st, of course. In more details, what is Go? So these founding fathers here, so I might add also Ian Landsteller, who's a GCC guru, who provided a GCC front-end to Go. When you have GCC, you can actually compile Go. But so Go is also a concurrent-oriented language, hence the title of the presentation. Go is also garbage collected, so you don't have any more memory leaks. So one less delay compared to 1 to 2. Hello. So it's also open source under a very general programming language. It also has the feel of a dynamic language and the safety of a static type system. So, of course, when I'm selling it to you like that, few times, few talks, can't really just see that just from the hello world or something like that. Believe me, or better, don't believe me. It's also compiled down to machine language, so it's fast. Usually, plus or minus 10% around C. The performances of C. It's object-oriented without classes, but it's with classes. Object-oriented programming. It has also built-in notation. Characterization to JSON or something. And you have also interfaces like or Python. And you have it on all of the major platforms. Android, iOS, and on ARM, AMD, 386, whatever. Give me an architecture and go with one. For concurrency in Go, there are two main pillars in Go to do concurrency. The first one is a coroutine, which is basically a very lightweight thread. So it's not really like a native thread like in C++ thread or post thread or handles, but it's a very lightweight. It's a lightweight thread which has its own stack, which can grow or shrink as needed, so you don't have any more stack overflows like you might have in a C++. And so it's very cheap, so you can have gazillions, millions of coroutines running on a very cheap laptop like one of yours. So cheap. Can run it. So you can think of it as a very cheap thread, and you won't be far off of what is what are. So a very simple example of Go routines. So you have a function f which takes a string message and then a delay time. You have an infinite for loop which will print the message and then sit for some time. And like that, an infinite. Once you call that function s, it will just run forever in that infinite for loop. And in my main function, I just have to call this function s with some parameters. Click and go, the keyboard go in front of it, and this function s will run inside its own thread forever. And I can run part of 3 functions like that, 3 routines like that with go to run in front of this. And then see for some time to see what happens. And yes, that. So you can see that each of those routines, A, B, and C, print some messages. But after 20 seconds, so if I can keep some time here, speak like that, and words out of my mouth, you can see at some point that So I have this infinite for loop which prints out messages for each of the routines. So very simple to start off executions in like many Go routines. And the function f is a regular function in Go. You don't have to make computation to execute it in on Go routine. You just have to prevent the when you use it. But that's one of the pillars, because here I'm just starting with launching the routines, but and you have the illusion of the communication routines stuff on the output, but there is no real communication, so it's useful. To have something more useful in Go, we have the channels, which are a type from width, which can establish data communications between all of those Go routines. So the syntax is not very important. But basically, you just you may create a channel of integers like that. So I declare a variable ch of type channel of int. I initialize it like that, and then I can send the value 1 through the channel like so, or extract a value from that channel like this. And the channels which are created like that are a way to synchronize the execution of two routines, because you can't send a value through the channel from one end as long as there is somebody on the other end of the channel that tries to but like a relay race of two people trying to run with the baton. The first one, the first runner has to be close to the other one and give the baton. So for the race, synchronization and communication. So here I'm just reusing the same example. Here I take additional parameter, the channel strings, and in my for loop, infinite for loop, I try to extract to send data this message through the channel and then sync. And then here in the main function, I create a channel, pass it to all of the routines, and loop for 100 times. And I do have exactly the same behavior, except that now I can see.
Both specify to which group?
No, the first one that extracts the data works. So, but the order in which the data flows through the channel is the same. So it's not interesting. Just have one minute. So this, yeah. So Go is great. That's it. It's actually used in all of the cloud computing types. Okay, yeah. In all of the, funding of all of the cloud computing that we have now in the private space. So at Google, of course, yeah, it's born, but also in Mozilla, New York Times, Docker, even in SpaceX, we have Go monitoring code which monitors rockets. Not rocket science, but it's a language which is being. But what about the HEP or astrophysics and physics? Well, what about it? There's Go-HEP, which tries to use the chasm of Go for HEP. So Go-HEP is actually Go-HEP.org is a set of pure Go packages which provide a few building blocks to be able to do a basic analysis for HEP. So you have histograms, plots, fits, are all written in pure Go. I'm also for my lab, I also have written a few AHU systems and monitoring systems. And for just to convince myself that it's not easy work, me doing something to have fun, I also wrote a little fast simulation tool. Like in every Go package, you can just go get it, like using Go-HEP. So you point at a GitHub repository, it will clone the repository, inspect the source code for all of the dependencies, and then retrieve all of the dependencies, build them, then pass and finally compile and install. No makefile, no symmetries, no problem that expect. We are in 20. So here is the laundry list of a few packages like the FAS, my FAS detector simulation. Echelon framework, which is a framework edgebook, because I like the old names of the Quantum era, and a few packages to read files in Go, in Foundation, also events, HEP PDT, also LCIO to do linear collider studies, yes. Rio, which is my own record IO, and root.io, which is a Pogo package to read roots, roots. And a few commands, so like root ls to inspect root file contents, or root serve to spawn a web server to inspect the content of your root files on pictograms and tissue branches, and also Pogo, because I like re-implement Po in Go, and for the fun, of course. So FAD is basically a re-implementation of C++ dev into Go. Use PHP for describing HEP-LC to read and write HEP-LC stuff, using a framework to do all of the concurrency of event-level parallelism and sub-event level parallelism. The documentation which is up there. Again, you just have to say go get and then the name of the application that you want to install, and you put it as well as the dependencies, no makefile, nothing in my fields. Just fast through the slides. So I just rewrote a little Delphus class simulation in using a FAD thing, and I implemented a few components of the FLC converter. The V tagging, the magnetic field, and that kind of stuff. So all of the containers that FAD is creating, calculating through all of those algorithms. I just timed it against Delphus on this 64 cores machine with well, some kind of Diffie server, let's say. So this is to show the number, the amount of memory RSS against the number of threads that I'm running. So in red, this is FAD, and the flat line here is the memory usage of that. So you see that around 30 parallel threads, I'm still less memory than the first application. And now this is the event robot, and you see here that event robots, and already with only one thread, I'm faster than it. That goes off here is the number, the hyper-threading line of. So good RSS scaling, kind of good, and also, what's importantly, bit-by-bit matching Delphus, and having an answer very fast, but wrong one. With that, I will just skip, but I'm twice as fast as the original with C++ implementation. And I will just go to root.io very quickly. So here is the web server, which takes files, and I can click on one of those branches. And I also compared root.io performances between my implementation, and I'm just twice as slow as it. There's still some work to be done for me to be not the first one, but I'm not doing all of the optimization that I'm any component point of view. So basically, Go is a great language to try for you to try out, I think. It fixes a bunch of the C++ and Python issues. And well, even if for Go, for Go, you still have a few scientific-oriented libraries which are still missing. Already you can do a more multi-core, many-core environment. So Go is, I think, around here. So maybe write your next tool analysis in Go, and if you want to have more information about Go and meetups about Go, there is this website for which you can go there. So at the machine level, it's just the channel is just an abstraction on top of that, which in my view is way more easier for a human to resolve instead of blocks barrier. So FAD is my 20% work on the side that I did for a couple of years, but I don't know how many months, year or month and hours did I put in. Yeah. Well, of course, would be Jingo, but that's, I tried it with a few students, master students, to try to rewrite a little cosmology analysis. And he had no C++ experience, a bit of Python programming experience. 1 week he was able. Very easy to do. Well, in Go, you don't have class, so you don't have the inheritance like in C++. You have the polymorphism, but there is no, you can still do object-oriented programming. Yeah. No, I had a clean room implementation of both parts which was working. A few papers on the site. I was answers, but other except for the names.
But are there standard scientific libraries for things like linear algebra, etc.?
Yes. So there is this project called Go-HEP, which is more or less the sci-fi NumPy of Go, and in there you have class, LA hash, optimizers. You have a fair amount of in Go, more or less on par with possibly what's missing.
To interface with policy function.
Yes, so you can call a C function or a Fortran function which has the ISO binding of by just comment in your Go source code saying I want this header file, and then you just have to say the name of the function and you can copy it.
So, Go is the only language across.
Yeah. But before going to Go, I went through the other languages. So I tried Rust, I tried Scala, I tried. But in the end, the first time I saw Go, I said, nothing really new under the sun. But the thing which really was the environment of Go, how you quickly start, how you can
process.
which should, Capo should be really the name. But so really an ecosystem which is really nice to really put.
But in Go, you still have databases or multiple class accessing.
Yeah. So only Rust has a very to prevent databases at the computer. But Go has a integrated waste detection. So Go get -waste your project, which will recompile it, instrument it, and then you can detect wastes like that.
I know, so it's also compiled language, but it seems like, the examples we're showing, it's like, you just started with the source code and it does the compilation on the fly, basically.
Yeah. So in the mode that I showed, like with this Go one, this is basically when you just have one .go file or a few. It's just to quickly iterate on a few things right on the side. But the Go-Get way is for more structured and deployable code. Say Go-Get or Go-Install, and it will compile a .exe file, put it on your disk, and then you can SCP that .exe file on all of your Linux machines or all of your Windows machines. And use that binary. And as Go compiles by default to static executables, you can very easily deploy that code, and you can also very easily cross-compile from any machine and operating system to any other machine and operating system. Go OS Windows and Go Arch 386 and Go get my package, and you can then from a Linux for a Raspberry Pi or whatever which can be.
Actually, you look at the list of other languages. Go. Do you look at it?
Yeah. So I looked at Julia, and when I looked at it, I said, yeah, this will be the killer of Python. So I kept on looking at it. But I think that these days, the original momentum of Julia has very focusing on but I think that Julia has still a few things for being Python. The thing that I didn't plan, but I had to rewire my brain to use people-based indexing and otherwise in ways from where I went from Fortran to and rewiring my brain to Julia.